In the last class, we had studied about the transformation of liquid to solid. Okay, that is, we have discussed about the melting point and the freezing point. Okay. Now today we will be discussing about conversion of liquids to gases. Okay, so this type of interconversion, you can say it conversion from liquid to gas. Okay, when any liquid is changed into gas, or you can say it is interconverted into gas, then some of its properties become changed. Okay, what happens is the intermolecular force of attraction, which was more in liquid, when energy is supplied to it, okay, it gains some energy and it reaches to that point at that temperature where it gets converted into gas, then that is known as the boiling point of that liquid. Okay, where that liquid is turning into the gas. For example, for water we can say that water, it boils at 100 degrees Celsius, means at 100 degrees Celsius water will change into water vapor. Okay, so this is the point we are discussing, is about boiling. Boiling, it is the process by which liquid is transformed into gas at the atmospheric pressure, is known as the boiling. Okay, and the temperature at which boiling occurs is the boiling point. So if we want to define boiling point, then it can be said as it is the temperature at which liquid changes into gas or vapor at atmospheric pressure. Okay, for example, boiling point of water is 100 degrees Celsius. It means that at 100 degrees Celsius water will change into water vapor. Okay, we can write it in this way: H2O liquid at 100 degrees Celsius gets converted into H2O. So basically, when this is happening in an open apparatus, when you are heating water, okay, and when the temperature reaches 100 degrees Celsius, then water will start boiling and start evaporating. Okay, it will evaporate and in the form of water vapor. Now there are some effect of addition of impurities, like when we add impurity in any solvent or in any compound, then normally the boiling point of that compound increases. Okay, so we can say that if any impurity will be present, then the boiling point of that substance will increase. Okay, so normally boiling point increases with addition of any solute impurity. So this was about the boiling by which the liquid are converted into gases. Now, how do we convert liquid into gas? There are different processes by which liquid is converted into gas. For example, all the liquids, a pure liquid is having a particular boiling point. Okay, it boils at that temperature, and this is very useful for converting liquid into gases. The process used for the conversion of liquid into gaseous state by boiling and then condensing, then that is known as distillation. So here we have understood about boiling. Now we'll take a quick review of the word condensation. What does that mean? Okay. Condensation is conversion of gas into liquid. The process by which gas or vapor gets converted into liquid is known as condensation. Okay. Now when the gas or vapor is condensing the word we use when it is getting converted into liquid. Okay. For example, as I have told you about the conversion of water into water vapor, similarly we can take water vapor when it is condensed, then it forms H2O liquid. Okay. So here the process which is followed is condensation. Means water vapor is condensed and then it forms liquid water. Here the process we can write it as boiling in the above case. Now we can see that boiling and condensation both are opposite processes. In boiling, liquid is getting converted to gas, and in condensation, gas is converted to liquid. Okay. So these both are opposing processes. Now I was talking about how we will convert liquid into gas and how that pure liquid can be obtained. Generally we have liquids which are generally, you can say, they are having some impurity, or we have a mixture. Then how do we get the pure liquid? So this process generally involves is the distillation. Okay, we involve the process that is distillation. It is a method by which we can separate the mixture of any two compounds. Okay, now that for also a necessary criteria is required that one of them should be more volatile than the other. Okay, so we will be studying now the method of separating compounds. Okay, and those compounds which are having difference in their boiling point. So that is the distillation. It is a method to separate volatile liquids from non-volatile impurities. Or the second is liquids which have sufficient difference in their boiling point. Now in this method we separate volatile liquids from non-volatile impurities. Volatile means what? Now the meaning of volatile is that which forms vapor easily, or that which is having low boiling point. Okay, so that is the volatile liquid. And the non-volatile impurity, it means that the impurity, it is having high boiling point, so it does not convert into gas easily, so it is non-volatile. Okay, so these two terms are opposite of each other. Volatile means it gets converted into gas faster. Okay, now what is the principle involved in this method? The conversion of liquid into gaseous state by boiling and then condensation of gases into liquid. So this is the principle involved in this. The liquid is converted into gases by boiling, and then by condensation the gases are converted into liquid. Now this liquid is the pure liquid. From this all the impurities are removed. This is the principle involved in the distillation. Now distillation, there are different types of distillation. Now we'll see the types of distillation and we'll study them one by one. First is the simple distillation. Second is fractional distillation. Third is vacuum distillation. And the fourth one is steam distillation. All this method is involving the simple principle, that is the conversion of liquid into gases through boiling and then condensing the gases into liquid. But for different types of liquid and under different conditions, we have to use these different types of distillation. Okay, each one is having its own significance, why we have these types of distillation and what is the difference between them. We'll go through that now. So we'll be studying the first type of distillation, that is simple distillation. We'll see the apparatus, how the apparatus are arranged, and then we'll be able to understand it more easily. This is the arrangement of the apparatus in the process of simple distillation. Now we will name these apparatus. This is the round bottom flask. This is a condenser and it is a Liebig condenser. Here the arrow I have shown, from here it is the water outlet, that water comes out, and this is the water inlet. Here is present the liquid plus impurity. We can say there are present the mixture which is to be separated, and here is the pure liquid. This is the receiver. Here is the thermometer. Now the round bottom flask is attached with the condenser. Okay, here this narrow tube which I am drawn between the condenser, from here the vapor passes. Okay, and what happens now, we'll see this, what happens in this process. Here the liquid is present with the impurity. Now when it is heated, it reaches to a temperature. We'll see in the thermometer what is the temperature. Now whichever is having low boiling point, that is whichever will be more volatile, will form vapors. Now here the vapors of the liquid will be formed. Okay, vapors will be formed in this way, and these vapors, they will be passed through this tube, narrow tube, to the condenser. Now what happens in the condenser? When here the gases pass through the condenser, the water which is flowing through this inlet, water inlet, it comes and it makes the system such that the heat is transferred from the gas to this water. Now the water, it becomes little hot, and from here the hot water comes out. In this way what happens, the gas, it's losing its energy, it's losing its heat, and that is why what it will start condensing. It will start condensing and it will come down. It will come down in the form of liquid, and here it will be accumulated in this receiver. Okay, this is the pure liquid. Now the impurity will be left behind, and only in this way the pure liquid will be evaporated. Okay, it is vaporized and then it is condensed. Okay, so here in this process we can see in the round bottom flask what is happening. Here the boiling of liquid is taking place. Okay, and the volatile liquid, it converts into gas. It passes through this condenser where it loses its energy, and that is why from gas it becomes condenses to liquid, and then it is collected in the receiver. Here we get the pure liquid. Okay, so this is the general diagrammatic representation of the simple distillation. Now which type of we can separate this, for example, mixture of salt and water, it can be separated. Okay, salt, it is non-volatile and water is volatile. Means non-volatile because salt will not form into vapors. It will, even at 100 degrees, it does not change its state. Okay, whereas water, it vaporizes and it becomes gas. So here water vapor is coming up near the outlet from where it is entering the Liebig condenser. Over here it is getting condensed, that is from gaseous state is getting converted into the liquid state, and here we are collecting the pure water. In the second example we can also see, for example, we can separate chloroform and aniline. Chloroform is having boiling point of 334 Kelvin and aniline is having boiling point of 457 Kelvin. Okay, so here we can say chloroform is more volatile, so it will vaporize first and it will be collected first in the receiver, whereas the other non-volatile will be remaining behind. Here we have to see the temperature, it is maintained. Okay, volatile liquid converts to gas and then passes through the condenser and here it gets condensed, which is connected with the receiver where this pure volatile liquid is collected. And non-volatile component remains in the round bottom flask. Here the important point is, as I said, there should be difference, that is more than 30 degrees between the boiling points of the liquids. Otherwise what will happen, if the difference will be less, then the second liquid will also start vaporizing and then we'll not get the pure liquid. Here then we'll get both the mixture in the receiver. Okay, so at least the difference should be greater than 30 degrees, 25 to 30 degrees, the difference should be more. Okay, the higher the difference, the more easier we will be getting the pure liquid and the quicker. Okay, so this was about the simple distillation. About the three other distillation we'll be studying in the next class.